Hello, everybody, and welcome to today's technical steering team call for vOLTHA. Thanks for joining, and as usual, the call is public and recorded, so please be mindful of whatever you share during the meeting. First up on the agenda is that recently within ONF, it was decided to move and consolidate some of the Slack channels we had. We had a little bit one too many channels. And thus we decided to consolidate everything for the community projects and for outwards facing channels and discussions in the ONF community Slack. So all the vOLTHA channels have been already migrated, or at least it should be. If you're not registered for the vOLTHA, for the new vOLTHA, for the new, ONF community channel, please do so by clicking this link, and you can join there through a shared invite. Sometimes it has happened that a few folks have received an email saying that their account was deactivated. It might mean that you have not logged in since a long time. Just please do ping me. I have admin rights and I can reactivate anybody's account who was deactivated. But please do join this Slack channel. And we should treat it as the new de facto core Slack. Any questions? Okay. Then if not, let me proceed to the next item on the agenda. It's something else that I added is just a little bit of an update on our scale efforts. Recently, in the past few weeks, we have spent a lot of time improving the stack. It all started since an improvement in the OpenOLT agent and adapter for scale for flow replication. And out of that, if you're interested, you can ask more details to Girish. And that brought the adapter and the OLT agent to be a lot faster. And that yielded requirements to improve elements across the rest of the stack. So there was a lot of improvements that needed to be done in the ONOS applications to further do thread offloading and handling of sockets in the proper right way. And also there were some improvements in the vOLTHA core, and there's still a few things that need to be tweaked. But as of basically yesterday, we are in a very good shape, as you can see from the scale dashboard here. And we have successful passing jobs for most of our test cases. We still need to investigate some DHCP issues, especially with the Turk Telecom workflow. That needs to be understood. But most of our stuff is actually now working, which is incredibly good. So, Theo, do you want to add anything? Suraf, any comments that you want to make on this?
I think you gave a pretty good summary. If you are interested in the details, we are going to go through them on Thursday at the scalability call.
Okay, thanks, Theo. And thanks everybody who collaborated on this, especially Theo, Girish, and Pierre from ONF. There was a big push from ourselves, including myself, for this, and it was a great achievement. The stack is faster, and I think it's very good to have it, to have these improvements. Okay, any questions before we move on? No? Okay. Okay. Next up is a topic that was ported over by last time TST, and that is the discussion on support of MPLS pseudo-wire encapsulation on the OLT NNI port. from DT and especially Manuel Paul. So Manuel, if you want, you can take it over from me and share the screen and do a little bit of presentation.
Yeah, thanks very much, Andrea. I have a few slides here on my machine. I'm going to share those in a moment. And actually, I think discussion may take between 10 and 15 minutes, depending on whether there are any questions. So obviously, questions are very welcome. And slides are not supposed to be a perfectly polished top-down presentation, but just to introduce the feature proposal and open the discussion with regards to what would be our high-level view on how this would play out in vOLTHA. Most of all, the control plane, but here are also some nodal implementation requirements to be considered, obviously, that I would like to briefly touch upon. And yeah, then from there, take some discussion on feasibility with regards to the control plane design and proof of concept implementation. Okay, starting with the goal. So what we want to propose is that we consider kicking off a solution design that allow vOLTHA to support MPLS pseudowire encapsulation on an OLT's NNI link. So that would mean on top of the VLAN schema being used today, allow encapsulation of such VLANs into pseudowires, which would greatly allow to increase the scale in the access network, and in principle free from any constraints with regards to such VLAN IDs, numbers, and their scale, which is, as you know, limited to 4094 in the hard numbers when we look at the encapsulation for C VLANs or S VLANs. So obviously there is different use and different deployment options with such VLAN schemas. So the implementation should not be a one-off, but flexible enough to handle flows in a way of an SDN-enabled implementation, an SDN-enabled architecture, obviously. And I believe the available vOLTHA control plane is a perfect starting point. So I'm not aware of any better, actually. So what would be required and what components do we need to consider? Maybe starting from the bottom up. Certainly on the OLT, the network element needs to have an agent or any suitable local API and respective abstractions to control the setting up the MPLS tags or labels and flows. Then an adapter, existing adapters would need to be extended to allow handling such flows, such API extensions. And so would do the vOLTHA control plane. So I'm thinking about the adapter to core interface, and there would need to be an app, control plane app, sitting on top of ONOS, looking at the existing architecture where such logic or the logic for MPLS encapsulation would be SDN controlled. Okay, so with that, looking at, or better say, jumping directly one level deeper into an architecture figure. Apologies if that is a little blurry here. Did a copy and paste. Hopefully the key components can be somehow identified. So we do see an OLT that is connected with its NNI link towards a leaf switch that may be any aggregation or service edge termination node. So in the CBA architecture, that node would be labeled in ASG, right? And considering that such leaf switch with a leaf spine fabric, as in this example, would be the point of pseudowire termination, we actually do have just one hop in the MPLS speak. However, that is not a given, and additional or other use cases beyond the very simple one, which I mentioned first, meaning increased scale for the existing architecture, could be where a pseudowire would extend and continue or actually run across multiple hops to a different termination point. So at those termination points, the mapping has to occur, and that mapping in all cases would consider layer 2 based mapping options. So that's not an IP or generic MPLS label switch path, but it's considered always to be focused on an MPLS pseudowire encapsulation. So from that perspective, some requirements that relate to such mappings, which are found in the standards and specifications and are pretty well understood, I believe, and pretty well established, can be referred to. So as said, the idea is that different ONTs and their access and aggregation at a PON network can be mapped into a pseudowire, which removes certain limitations on the VLAN schema use. There's also an example. I would not say that this should be seen as an example as shown below, how, for example, an inner tech, which is still present, the inner tech is a C VLAN tech, is transported across the PON network and then receives the so-called outer tech, which means an S VLAN or just another VLAN tech, which is added on top of this customer traffic at the PON port, would then be encapsulated into a pseudowire, which runs on or which gets initiated at the OLT NNI and then terminates at the PE node leaf switch. So with such a example, let's look at a few high-level requirements. These are, I would say, rather focused on the nodal implementation. So the control plane requirements and details on that are subject to further work or subject to work and not laid out here. That would also, I think, go a little bit too far at this point. But if you look at the set and refer to existing standards, which are mostly available as RFCs, we would statically provision pseudowires to be created or terminated at the OLT. So then there is a available specification for mapping or tagging modes to transport Ethernet pseudowires with VLANs, and such modes are known as raw or tagged mode. Those are required to be supported and to be configured. And I would say one of the requirements that we have also identified well ahead, since this has certain impacts on control plane and high level also nodal requirements, is that such a PE, such an OLT that acts as an MPLS PE, can become the endpoint of a multi-segment pseudowire, which then makes it a terminating PE or TPE as part of the RFC 6073. Right. So without too much detail on that, at this point, I'm already coming to my last slide here, which is a proposed approach. And today I really wanted to just take a chance or use a chance to introduce requirements and our intended approach in high level. So we would suggest that during the vOLTHA 2.6 development timeframe, feature design is being started in terms of understanding at a level well below what I've just identified as key components, right? We would look into what would be solution requirements so that a control plane development can take place in early 2021. And if all goes well, first prototype POC implementations can be done and become available by 2021 first quarter, end of first quarter. Yeah, so with that, that's really all I have. And yeah, I'm available for questions. Thanks for giving me the time and chance to present those.
Thanks, Manuel. Just a quick question. So I'm assuming that there has to be some interaction here with the Broadcom BAL at some point. Has there been discussions around supporting the MPLS labels?
Yeah, I think there are some initial explorations with regards to hardware support. So my understanding is that the hardware that is available and would be in scope here, including most of the Broadcom chipsets, series that we all well know well, would support such MPLS label stacking or tagging. Yes. So that being said, certainly what I would like to encourage at this point is to look into the roadmap for all of the other relevant components in the stack, including the BAL roadmap. And those are obviously additional and relevant aspects to be identified out beyond the pure hardware capability, where at least we can be pretty certain that most hardware sets would be in support of at least the 2-label and standard label stack.
Yeah, I guess the issue is being able to program that through the BAL API.
So when we had plans for going towards production, early this year, we got a commitment from Broadcom that BAL 2.4 was going to be the long-term supported version from Broadcom, which means any bug fixes that are required for the BAL 2.4 supported features will be actually fixed in 2.4 instead of just moving on to the next release, which is the cycle that we were going through before we reached that agreement with Broadcom. The problem with just moving on to the next version for a bug fix just means that the next version has newer features, which may actually end up causing new regressions. So it was very important to reach that LTS agreement with Broadcom to BAL 2.4, and that's what's been working very well this year. And so 2.4 is still what we are using. Now, this is a completely new. Yeah, sorry. Yeah, thanks, Girish. Yes, that's what I meant, BAL 3.4. So this will almost certainly require, not almost certainly, it will certainly require moving to a new version of BAL. Which is not LTS. So as POC work I can imagine that this can be attempted as a one-off, but that would also mean that it's basically an experimental version of, say, vOLTHA anonymous, right? Just like Val. The production line would still have to be on Val 2.4 and what we're working on in vOLTHA anonymous right now. Would you agree, Manuel? Am I making my, what we have as LTS and what this will mean in terms of Val?
I think so.
So understood that we would have to look at a new version, which would be right now not having that LTS status, and certainly that would be then subject to clarification with regards to the production use and how to reach LTS status, or how to agree on declaring LTS status for a future version, where everybody is right now using 2.4 and can refer to it as an LTS, as an available LTS version from Broadcom. Yeah, understood.
Okay. The next question I had was, if you go back to the slide showing the picture of vOLT, 2 slides back, I guess. Yes. So to understand this, if I just focus on the OLT, when you say outer tag mapping, okay, so that's the VLAN tag, which is what we are doing right now for, say, the DT workflow in the OLT. So the VLAN tags are not changing. What's changing is that in addition to the VLAN tags, we are now putting MPLS labels. And as far as I remember from the pseudowire specification, there's sort of 2 labels, right? The inner label is the pseudowire label, and the outer label is the one that's used for forwarding the traffic and from the ingress node to the egress node, with the outer label getting swapped at every router along the way, right? So am I right? There's still 2 label requirements before the VLAN tags?
Oh, yes, I think that's what we have tried to iron out a little bit more in detail, since those questions obviously come up when the node requirements are being looked at, the hardware capabilities are being looked at, and you're fully right, Saurabh, for the upstream in a sense of looking towards the up the path towards aggregation to the core network. You would have to have principal support for a standard label stack, which requires an underlying label switch path, so a path that can be switched along its route towards the target and across the labeling switch or label switch routers. In the downstream, meaning the receiving end from the perspective of the OLT, when there's an ultimate hopping being applied, then the LSP label would be removed and only one label, the pseudowire label, would remain in the stack and get received.
So,
receiving PE. Yeah.
That's right. So upstream, the OLT will put on 2 labels, and downstream, the switch that connects to the OLT will remove the outer label, and so the OLT will receive only the pseudowire label. So that is clear. Now, what is not clear to me is the rules for now I'm just looking upstream, right? The rules for putting on the inner label are fine. That just represents the pseudo wire. But the rules for putting the outer label are dependent on the rest of the network, right? It's dependent on, you know, whether you using, you know, some control plane protocol like LTP or OSPF when it comes to segment routing and so on, right? There are certain sort of dynamic protocols that determine, say, the rules for putting on the outer label. And so does this work then include control plane aspects that are that require the implementation of certain control plane protocols that are basically control plane messages being exchanged with the rest of the network in order to determine what is the outer label that needs to be pushed onto that stack?
Yes, so the control plane that is supposed to be handling this flow, right, make this an abstraction for an SDN resource like right now VLANs or Ethernet frames are being forwarded across this NNI and out from the PON system. Such control plane would need to be able to provision the local flows, and it needs to have the understanding of the topology. So you fully, you fully nailed that, Saurabh. So that is exactly one consideration when it comes to the northbound side of the control plane. So it can actually be a dynamic protocol. We are not envisioning to use any dynamic protocol, which would still be possible. Of course, you could catch it over here and then process messages like LDP or other dynamic protocols being used for IP and MPLS control planes. But we are not envisioning to use such a dynamic label distribution or even a routing approach. So we would keep everything as it is today. That's why I've highlighted the static pseudowire nature from the perspective of the OLT. So I should have also added that whatever happens within this area here, which would certainly have several options of using dynamic protocols, but this is out of scope from the perspective of what we would do in vOLTHA. And if you look at the CBA level, I think we would have solutions which would be able to extend the fabric to the OLT, which might be more or less in line with a common operation of a leaf-spine fabric. But I'm not looking at such a solution in the first place. So what I'm looking at is really keeping the architecture and the key functionality, or the basic functionality, better say, in place, which means also right now from the perspective of how this is run with the SVLAN or layer 2 based schema, there's no dynamicity in the interaction between whatever is done here, so this topology and this topology. So we do have an application, an SDN application that is able to understand the northbound, and, or better say, that is able to handle a northbound interface that would be used to exchange the topology information, receive that from a control plane or topology controller on top, and then provision the identifiers which would be required to match the the endpoints. Does this make sense?
Got it. Yeah, I understood. So what you're looking for is that, since ONOS is the one that programs the vOLTHA data plane, ONOS or some app on ONOS really has to have the ability to understand that for the DT workflow in the upstream and downstream directions, these are the set of labels that need to be programmed in addition to the VLAN tags that it's already handling today. And so it's really just an API that tells it, okay, these are the labels that we want. and in this particular direction, and then just be able to program that through the stack down to the hardware. I think that part is clear. What is not clear is that why does the pseudowire need to originate at the OLT? I mean, the same function can be implemented in the leaf switch as well, right? I mean, our previous experience with pseudowires and Trellis, this is exactly how we did it. It's the leaf switch that originates the pseudowire based on incoming VLAN tag traffic, which could be double VLAN tag traffic. In fact, that's exactly what we did. Depending on the combination of VLAN tags coming in, a certain set of pseudowire, actually pseudowire label, and but in Trellis context we used a segment routing label. But if the origination of the pseudowire happens in the leaf switch as opposed to what's connected to the leaf switch. So I'm trying to understand why that is not a possibility. That is not a possibility that has been considered.
It has been considered. It's actually the status quo. So apologies for not having included a figure from, let's say, what is the present situation, or what is the situation before this is introduced. This is only showing the, as I said, an example for the architecture with MPLS pseudowires enabled at the OLT. But you are fully right. I would say, existing solution or solutions would be that you run an encapsulation, service encapsulation within the leaf spine fabric, or in your more general speaking access aggregation network, and then towards the backbone. So yeah, you would have that encapsulation either by pseudowires or IP transport. So there are several choices, and obviously Trellis does have that capability. So the trick that we are looking for is, in order to remove some limitations of scale and VLAN schema use at this link, at this interface, we would have to have one level of aggregation on top of VLANs. And that is what the MPLS pseudowire encapsulation would offer.
I see. So because in the DT workflow, you don't actually touch the inner label, the C, sorry, not inner label, inner tag. The C tag is left as it is, whatever it is coming from the ONU. You have no control over that, right? And so it limits your options because you can only manipulate based on the S tag that you put on, the outer tag. And so that limits your scale, right?
Correct.
I mean, for example, this would not be a problem in, for example, in the AT&T workflow where both tags are sort of under the operator's control. But in the DT workflow, you can't touch the C label. So S tag limits your scale. And so that is the motivation for moving to OLT, actually doing the installation of the MPLS labels.
Exactly, right. And as said, right, the termination of, let's say in the simplest case, the termination that is the case, or the approach today at the leaf, would not change. So it's actually just an encapsulation that is added on this link, which stays local. And in that case, it's also from the implementation perspective, it's rather simple. However, what we are foreseeing, and that's what we didn't want to preclude or exclude in the beginning, is that other scenarios would offer, of course, leveraging this capability way more when you have an extension of pseudowires across the fabric, so that services can benefit from this transparency in terms of VLAN schemas all across the fabric, and not even do need to run and undergo a termination point. So that's exactly why I try to shed some light on the options that would be supported. However, from the OLT and control plane perspective, that the OLT vOLTHA stack would need to consider not seeing many changes or actual complications. Looking forward to additional use cases beyond this single link pseudo-wire NCAP.
Yeah, I mean, it's just it's a difference in what the flows look like and what the APIs look like exposed by ONOS. The real question then, I mean, it's not a lot of work in my opinion, at least compared to what it could have been. The real question then becomes, since we're using a new version, certainly using a new version of VAL that is not designated LTS, and do we also use experimental versions of the vOLTHA on a stack to do this POC, as opposed to the main line, which is headed towards production? What does the rest of the TST feel?
Can you phrase that as a question?
Yes.
No, can you phrase it as a question?
Oh, your thoughts, David?
Again, I'm gonna back up, and so my general thoughts on this is kind of what you said earlier, right? This is experiment versus non-experiment, right? I'm looking at resources and just wondering how this is going to happen. That makes sense?
No, so resources is one question. The other question is whether this is part of the mainline work that we are doing, or does this happen on an experimental branch? Is that what you're?
That's kind of, yeah.
Also hinting at, yeah.
That's kind of what I'm hinting at, yeah. The issue being, and I think you mentioned this earlier, right? We've got to get the core production quality. I feel like we need to focus on that. I want to say the structure, the foundations still a little bit, and I worry about continually adding new features before I'm convinced that foundation is as secure as it needs to be. Both in terms of, when I look at the foundation in terms of changes, some of the Kafka gRPC stuff to make stability. How do we do stacks? How do we do upgrades? Our failure scenarios. These are all things that I don't care what features we have. If these core foundational things aren't, in my opinion, stronger, then the new features won't matter because it's not going to be production ready. Does that make sense?
Yeah, absolutely. Any other thoughts from the rest of the TST? Amit?
I kind of agree. This is more an experiment to be done on its own private branch.
Thank you. Amit?
Yeah, so I think we have quite a lot of exploration still to be done on this, right, before we could get down to the architecture and design that would need to be done, right, to support something like this. So if we have the resources, I think then we can get started with the exploration at least.
Okay, thank you. Anyone else has any thoughts or questions on this subject? Okay, so So Manuel, from the feedback I get from the TST as well as my own thoughts is that it is best to do this on an experimental branch of the entire stack, starting from BAL upwards, and not put it in the main line. It also requires some actual resources in terms of implementation, given that our current resources are working on production readiness for the identified features in MBTP 2.0. The actual design is of this experimental work should probably happen in the 2.6 timeframe. It's if somebody creates a written proposal that we can discuss for the actual low-level details of how the ONOS changes, how vOLTHA changes, and so on. What are the API changes? So if there's someone who's willing to write a written proposal of the low-level changes, we'd be happy to discuss it in the 2.6 timeframe. Do you have someone in mind, Manuel, to attempt such a written proposal of low-level details? Or right now, this is just a thought? Yeah.
Yeah, no, we are planning to get there in the early December timeframe to hopefully be ready to make such a proposal. So yeah, that's why I'm saying we're about to look at this DT internally and kick it off, and that is, as you would understand, right? It's something we needed to also give some time. We understand that this timeline is going to be a staged one from the design towards the experimental implementation and then maturing it. So that's why we are suggesting it early. So yes, I mean, right now I wouldn't be able to define an exact timeline beyond the rather high level one I've suggested, but I would say by end of the year we would be targeting it, submitting a design proposal, or inviting, of course, community interested parties to work with us on that. And then we can also submit drafts earlier and mature it and grow it from there. And if there are thoughts or feedback on existing pieces, implementations that we could use as a starting point in terms of control plane and or API additions. So in that case, it's also very welcome to hear about those, and feel free to reach out to me in that case. And I understand that the approach can be taken to create an experimental branch and take it from there as soon as we have.
My initial thoughts are that it probably does not require a new app in ONOS. Basically, the OLT app is the one that is responsible for programming the data plane flows for all three workflows. So it's just in the, and it gets its cues from what it learns from status. So it's the status description were to include the desired MPLS labels, then it's fairly straightforward to have the OLT app understand the changes in the status description for subscribers and to execute the flows necessary for including the labels onto the on top of the VLAN tags for the DT workflow. that's my very initial thoughts. But like I said, we'll be happy to entertain a written proposal on the low-level details when it's ready.
Mm-hmm. Yeah, thanks very much. That makes sense, and we would be happy to plan submitting such a proposal. Yeah.
Manuel and Saurav, my comments on the low-level design. So the low-level design wouldn't be complete without documenting, the BAL APIs that would be used. But I mean, the current proposal is, by end of December we'll have low-level design. I mean, that's what I understood. November is just, December is just 1 month away, and we need to talk to Broadcom first in order to, have these, to propose these requirements and, have them release some initial APIs that we could use to configure these MPLS labels. So I think it seems to me a bit of a stretch. What are your thoughts on this?
Very good comment. Thanks, Girish. I think when I said design proposal, I was talking about the more or less following up to Saurav's thought on what would be the APIs in the stack. But if you look at the low-level APIs, you're right. Probably we need to say that by beginning of December we would have to have initiated a conversation on the BAL APIs. Maybe we would not yet have the exact low-level design how to use them, but maybe we could identify by that time in which form and release of BAL such APIs would be available, and which one or which APIs it would be. So meaning kick off conversation and an initial understanding on the low-level design. I agree that it could be a stretch to finish that already in terms of the exact low-level detail design using such APIs. But would you be available to help and join such a discussion on the BAL roadmap, Saurav and Girish?
Yeah, I would be happy. Saurav, you have anything to?
Yeah, I think the BAL Brigade call is a good place to have that discussion if you wish, or we can have a separate one too. That's your call, Manuel.
Okay, all right. Then I will take another action to reach out separately on kicking off a discussion, including the BAL Brigade's representatives, so that we get an understanding on the BAL roadmap.
Yeah, the BAL Brigade call is generally not, I don't think these discussions would actually fit in that short duration. It's 30 minutes and we hardly find enough time to discuss the current statuses of the ongoing work in the brigade. So I would prefer a separate call.
Okay.
Okay, thank you, Manuel. Any other questions on this topic? Yeah.
Okay. Thanks a lot, Manuel. I don't have personally any questions, and thanks a lot for the discussion. It was a very productive one. Please do include myself in the call, Girish, so I can also support this to the best of my capabilities. Okay.
Sure. Thanks, Andrew.
No problem. Okay. Next up is a fairly small topic that I think it's enough that we can take it on today. given that Serkan is on the call. I was made aware of the fact that the etcd version that we are using, which is 3.2.26, is not the recommended one for the production deployments. And this was brought to our attention by Serkan, that reached out to the etcd community, and they shared with him that the 3.2.28 version is a better one for production. So Serkan, do you want to give us an update on this? Any thoughts, or can you give us some more insight?
Oh, actually, that's the whole point here. So as far as I know, we are using the stock Helm charts from the GitHub/Helm charts, and it's an incubator version that we are using. So it's pretty an old version. I know the etcd version is currently, it's in 4.x releases. So, but in my tests, I don't know, maybe there's another problem, I'm not sure. When I use the 4.x versions, the performance of the etcd is very low. So we need to figure out why is there such a performance-wise differentiation between the releases.
So doesn't etcd support, don't they have some LTS version that they advertise?
They are just suggesting that the lowest versions that you have to use in the production environment, and the minimum version is 3.2.28 for the 3 release.
Okay, but let's say we would have, we would have to move. So apparently what the answer to your question, Surf, is that if we want to stick to 3, we need at least to go to 3.28, 3.2.28. But if we want to go to 4, is there a known LTS?
And what is the advantage of going to 4 other than it's the latest number?
Yes.
Yeah, I don't know that. We need to explore more.
Okay. Would you mind doing this exploration, Serkan?
Yes, actually, I'm working on that. Yeah, I can update later if I can find something.
Okay. I'll create a Jira ticket and assign it to you, so we don't lose track.
And what Helm chart are they recommending? If not the incubator etcd Helm chart, which we've been using. I mean, the etcd operator seems to have gone away. So yeah, what's their recommendations?
The Bitnami etcd charts seems pretty well. We can think of using them.
Yeah, I've heard of those. Again, that relies on them, as opposed to, I mean, I'm not sure that's more official than the incubator chart, but okay. Do we know the differences between the two?
The Bitnami etcd charts are more configurable as far as I see. You can, the values YAML file, there are lots of options. It seems they are all open. But in incubator etcd Helm charts, there's almost half of them is exposed to in the values YAML. Maybe that is because of the different versions of the etcds. But even in the Bitnami etcd charts, the version of the etcd in values.yaml is not the production versions. But I think and I hope it can be changed.
Okay, then maybe Serkan, do your investigation. I think this is better if we can put it into maybe the long-term support release, and if 2.6 is going to be the long-term support, we should have this into 2.6. And yeah, let's continue that. That if you can keep us posted, I'll put this on Jira and possibly on the roadmap.
Also, is it possible to scale test and see the difference in ONS hardware?
Yes, we could schedule some of that. Given yes, let's maybe take it into the scalability brigade to see the differences. But I think that is doable. Maybe not like immediately. We're still like addressing the latest minor issues that we're still seeing, but I think it's doable.
Okay, great.
We can definitely find a time to schedule some scale runs to make sure we maintain the performances.
Yeah, one thing maybe on that, Serkan, if you can, it would be good to know that 4.x works with the vOLTHA stack before scheduling the runs, meaning that if we see any failures, we can definitely attribute them to performance regression rather than functional regression.
But I don't think we are talking about 4, right? We're talking about 3 to 28. Right?
I thought we were talking about 4.
Serkan, are you asking for scale runs on 3 to 28 or 4?
Well, again, some of this we got to remember. This is just what are we certifying things with, right? etcd, well used by vOLTHA, isn't part of vOLTHA. So in theory, someone can deploy etcd any way they want, and may not even be in Kubernetes. They can have it as a separate install somewhere else, and they can, in some sense, deploy any version they want. The question really becomes, what versions are we going to certify against? Right? All we care about is an etcd API. I don't care how it gets there.
Yeah. Well, point is, we do need an etcd version. So I guess our question was, if we have to pick one for the 2.6 release, would it be 3.2.28 or would we make the jump to 4? My understanding was
one was 3.2.8 released, and one what version of 4 are we? What release date on 4 are we looking at?
Serkan?
I don't remember the exact version numbers, but I can send in the Slack channel.
Yeah, it's part of it's a release date. For instance, it's 3.2.28, a year and a half old, and 4, just picking a number, 4.0.0 is 3 months old. Right? I mean, are we talking that big a differential? Are we talking bigger or smaller? Right?
As far as I understand, they are backporting some of the features into the old versions. So 3 and 4 versions, they all have the production versions, but I don't know the difference, the main difference between 4 and 3.
All right. I think just some more information is going to be needed.
Yeah.
Yeah, if it helps, I've been working with 3.4.10 from the Bitnami distribution. I'll post some information on that on the Slack channel. That's
yeah.
You said 3.4.10, Chip?
Yeah, 3.4.10. I was just wanting a simpler single pod, single container pod to run etcd for my development test. And
is that the version of the Helm chart, or is that the version of the Helm chart or the etcd image?
That's the etcd version. The version of the Helm chart is 4.9.1.
And is it okay? Is it their specific build of an image?
I'd have to look at exactly everything for it, but it seemed.
And it can deploy a cluster. You said you're using a single pod, but presumably it can deploy a cluster too.
Yeah, I'm just doing a single one.
Yeah.
And I've got persistence turned off and also RBAC.
Yeah, again, this is some of that configurability question is going to be interesting because the incubator has configurability as well, right? What additional features and configurability are we looking at using?
Okay.
Those type of questions. Also, is it an operator model? Or I don't think it is, but
it's not. I don't believe.
Yeah.
So essentially, what I'm hearing, and then I think we have to close because we're more than 10 minutes after the hour, is that some more investigation is going to be done by Circuit, and when more information is provided, we can then decide whether to go to 4.x, 3.4 something, or that. I think this is going to be maybe a long-lasting item. I'll reschedule it for next week, so maybe next week we can have some more information. Would that sound okay?
Yeah, it's okay for me.
Sure.
Perfect.
Okay, then thanks everybody for joining. I'll publish the recording. Thanks for the great discussion. Thanks, Manu, for the presentation. And let's continue the great work on Slack, on the email, and I'll talk to you next week. Cheers, everybody. Bye-bye.
Thank you. Bye.